Okay, so now we want to look at how can we integrate the double integral using polar coordinate system, which means that your expression is in terms of last time you have the function, the integrand in terms of xy, and let's say you have an order dx dy and your region also lying on the xy plane. Okay, so now what we have is you will convert all the integrand into a polar equation. So let's say you have you will have another different expression, but using the given expression in x and y. So when you convert into r theta, you will have another form. Okay, and then your so I just put the dA first. So I will explain to you what is the order of integration in polar, and you are also still on the xy plane. Okay, but your dA also not in terms of dx dy anymore. It maybe dr d theta or d theta d r. But I will explain to you what is the dA for. Sorry, it's no longer okay. And yeah, dA for the polar is no longer dx dy. It should be dr d theta or d theta dr. But in this case, it's not exactly dr d theta or d theta dr. There is another term that you have to put into the dA as well, but I will explain later. Okay, so now how can you know you should transform your double integral in Cartesian into polar? So how can you know that? Okay, actually, as I mentioned before, so we have two different kind of region. So we have a rectangular region or non-rectangular region. So the rectangular region that we have seen so far, you can see the circle, so you can see the triangle, and you can see some a shape of the region, right? Some shapes of the region, which is they are not a rectangle. But if your region here is a circle, okay, it's a circle, whether it is centered at the origin or shifted somewhere, then it is better for you to solve your double integral in polar coordinate system. So with the condition that you know how to convert from the Cartesian to polar. So that's why I told you your lesson in engineering math 1 about the parametric equation and polar equation. They are very important, and I'm sure that you still remember the polar function, the polar graph. Do you still remember that? And there is a test that you have to obtain just to help you to know where is the symmetrical, is it the curve symmetrical along the x-axis or y-axis, isn't it? You still remember that? And you have a cardioid and love shape. You still remember that? Now you need them again in this topic. Okay, so that's why I told you, if you don't remember that, so please refer to your previous note. If you have bought a book which is for the engineering 1, then you have to open them back, because in that book you have the material about the polar, so that is very important, especially for the polar graph. So you can use that book as a reference, and also about the integration technique. So I'm sure that also provided in that book, then you have to refer to that book for your own revision. Okay, so that is about the polar coordinate. So so what is the variable that you need in the polar? We have r and theta. So as we know that theta is the angle, so let's say you have a point P here, so you got a point here, and the r is the length of this point from the origin, and the theta is the angle from the x-axis positive to that line OP. So these are all the relationship that you have seen this in engineering 1 as well. where we know that y always defined as r sine theta, and x always defined as r cos theta, and y over x is equal to tangent theta. Or if you want to get just theta, you just have to obtain the inverse tangent of the y over x, so you will get the theta. And I'm sure that previously your lecturer has already remind you that if you set your calculator, especially to get the angle here, if you set your calculator in radian mode, so the result of your given by the calculator is radian. If you set your calculator in degree and the theta here is degree, so you have to be aware with that and should be noted. Okay, so this just so you can read this by your own. Okay, so now in terms of I want to explain to you if for Cartesian, we know that the order of integration, whether you have dx dy or dy dx, where the idea how we get the dx dy here, just like you multiply the changes of x and the changes of y, just like you assume you have a very small rectangle and you have the change of x and you have the change of y, and you multiply, then you have the area. So that's why we put the a here. We assume that the change of the area where we have a very small rectangle. So that one I already explained to you in the beginning when we just entered this chapter 3, right? Okay, so now we want to obtain what is the dA in polar. So you instead of you have xy, now you have dr and d theta, because that is the variable exists in the polar function, right? R and theta, or you can have d theta dr. But for dA, there is something that you should be added as well. There is something there, which is it is a r, also this one. So you have to take note this, okay? And why we have that? So I will show you from this diagram. Okay, but normally the simplest calculation or the simplest way to determine the r and theta, I mean it's not just like the Cartesian where you can have the dx dy or you can have dy dx. Both are common, okay? But for polar, what I want to say here, the a bit simpler form is always belongs to the d theta. So you can see this all the time. You always use the d theta instead of d theta dr. So this one we use a bit something not common, because I don't want to say it is complicated, but the way in producing the limit is not so direct as the dr and d theta. So that's why here I will say that normally you will always use the dr theta instead of d theta dr, but still possible to be done. Okay, so the idea here is if we so because we have the circle, right? When we region is a circle, so then so let's say you have the so that line is correspond to the let's say this is theta 1, this is theta 2, because we know that the theta is angle right from the x-axis positive. And then r, what is r? R is the radius of circle. So let's say you have a r with some radius and another r, you have another radius of circle. Okay, so now this one is given by r1, where the radius of the circle is r1, and then the other one is the radius of the circle. The radius of the circle is r2. So when we take out this one, so we the region which is bounded by the theta 1 and the theta 2, and also r1 and r2, So we have a wedge here. Color. So we have a wedge here. So now we take out that wedge. So when we take out that wedge, so this is our R, the region where it is bounded by two lines, where the straight lines is telling you the angle. Okay, you remember that? When you have a method in Mat 1 before this, in the polar equation. So when your theta is equal to, let's say, pi over 3, so what is the graph that you have? You still remember that? So it is a straight line passing through the origin, where that, and the slope of that line depends on the value of the angle that you have, which is this is pi over 3. So this is not degree, this is radian. But if you want to have in a degree, so you have to convert, so it's become 60, right? 60 degree. Okay, so now we want to find out what is the limit of R and what is the limit of theta for that, from if you have your region is part of the circle and also with some angle. Okay, now let's say that is the R. This is your R now. Okay, where it's bounded by the theta 1, the theta 2, and also R1 and R2. And imagine this is very, very small, where the R1 and R2 is approximately the same. Okay, the value there of the big, because this we are taking something very, very small. So here R1 and R2 is almost the same. Okay, so now in terms of, we want to obtain the area of this region, which is if you look at this is not exactly a rectangle, right? Just a wedge of part of the circle. But because this is very, very small, we assume that R1 and R2 are exactly the same. Okay, where we can just say that, okay, R1 is almost the R2, where we call this as the R. We have just R because the value of them is almost the same. So now, because of this is part of a circle, so in order for you to determine the length and the width, is we have to refer to the arc length, the formula for the arc length. So arc length is the length over here. So the length for this is, okay, the length of this is given by the changes of the R. So we call it as the delta R, the changes of the R, delta R. Okay, and then the length for this is, because this one is the changes of the theta, not the length, alright? But then how can you have the arc length? What is the formula of arc length? Arc length is R theta. The formula of arc length is, so the formula of arc length is R theta. So in this case, when you have you want to find the area, so the area is the, what we call that, the length and the width. How can we spell the yes, length multiplied by the width, right? So the length is delta R, and the width here is arc length, so which is R theta. So because of this one is delta theta, we don't have just theta, so we multiply the R. Okay, the R, the single R, and delta theta. Not A, sorry. Theta. So that is the arc length. Length. So in Malay, this called panjang lingkup R theta. R kali dengan theta. So your theta is not theta, but delta theta. So to get the arc length is R multiplied by delta theta. Okay, sorry, I should put the delta theta. So now we have length. The length is delta R multiplied by the width. The width is the arc length over here, which is from the R delta theta. So when you simplify that, so you can bring R. R is the radius, R delta theta. But instead of we use the delta, we just use this because we want to relate that with the order of integration. So we put the delta to be dr, and delta theta to be d theta. So that's why we can see that this one is this is delta A, right? So the area is given by r dr d theta, not just dr d theta or d theta dr. So meaning that what I want to say here, you have to always bear in mind in polar your dA is r dr d theta, or you can also have r d theta dr. So that is the thing that you have to take note in polar. When you solve the double integral in polar coordinate, your dA should be put the r here, just r, and that r will be part of your integrand that you need to integrate later on.